Okay, so we're going to look at this question. This is a very challenging question from the year of 2014, paper 2, question 6. Alright, this is one of the hardest questions ever to come out in for refraction. So let's read the question. A small lamp is 2 meters below the surface of water in the middle of a large swimming pool, as shown in figure 5. Two rays from the lamp strike the surface at x and y. The critical angle of light passing from water to air is 49 degrees. So the first question is explain in words what is meant by critical angle. Now, so this definition is not so difficult. If you have seen my previous video, I already explained. So let me just re-explain. Critical angle is simply defined as the angle incident in the optically denser medium, where the angle of refraction in the less dense medium is 90 degrees. Alright, so you must remember that critical angle and all these ideas of total incident refraction only happens when it's traveling from dense to less dense. Okay, and for critical angle, the angle of refraction on the other side will be 90 degrees. Okay, so next move on. On figure 5, complete the path of the two rays as it strikes the surface of xy. So because this is the critical angle, alright, which is 49 degrees, so that means that for the second ray, which is y, the angle of incident is already critical angle, and so we'll expect that the light ray will travel at 90 degrees after refraction. So for this case, okay, the first ray will travel in this direction. If you cannot see, just remember it's actually travel like that because the angle of incident is 90 degrees. Now for this one, if you look at carefully, alright, and you draw the normal, you realize that this angle is smaller than 49, alright. So if the angle is smaller than 49, so it will be angle incident is lesser than critical angle, so you refract away from the normal, but it will come out from the surface to the air. So that means the second one will be something like that. Okay, so this will be the answer for the second. The ray will go this way. Okay, so the next question is the one that's very challenging. Okay, when viewed from above the pool, the light from the lamp emerges only as a circular area of water. Explain why this is so. Now this is a very challenging question which requires a little bit of thinking. Let's revisit the diagram again. So this is the lamp and this is water, while this is air. So we need to know that when the ray is incident at different angles, it has different effects because of this judgment. Angle incident lesser than c, it bends refract away from normal, but it emerges into the air. Angle incident equal to c, it will refract at 90 degrees. For angle incident greater than c, the rays will not come out from the surface, but it will reflect back inside. Okay, so we let the rays be denoted by different colors. The blue one are rays that are tighter. That means that the ray of light does not goes in a tighter angle. So this angle is less than 49. If this angle is less than 49, alright, it will be less than the critical angle, which is 49 degrees. So it will refract away from the normal. So we will expect it to go like that. In the same way, on the other side, it will go like that. Go like that. Okay. But then, if it is at 49 degrees, it will go like that. Okay. And then the third one, which is in black color, if you look at this, the third one, this is an angle that's even larger than 49 degrees. So if it is even larger than 49 degrees, okay, let's look at this again. It's larger than 49 degrees. Total internal reflection happens. So the third one, the ray will actually go back in. So if you look at this case, right, you realize that from here, all the way to this point, light will emerge. Okay, but for this region onwards, no light. And so what happens is that it tells us that if there is a limit beyond a certain angle, the rays does not emerge. And imagine this repeated all around in a circular fashion, we form a circular cone, right? Where anything that's lesser than the angle of critical angle emerges, anything more than critical angle, it does not emerge, right? So how do you write in words? So this is my proposed answer. Okay, so light rays incident further than the y, which is this point, this is y, so it's further than y, okay, has an angle of incident greater than the critical angle, leading to total internal reflection and no light leaving the pool, right? So that means the angle of incidence is greater than critical angle, so no refraction, no light is emerged. But rays incident nearer than y has an angle of incidence lesser than critical angle and will refract into air, forming a circular spot. So that's the reason why it forms a circular spot. I think that this answer will be enough because there's only 2 marks, right? So the last question is to calculate the radius. Okay, again, it's a very challenging question. How do you calculate the radius? Okay, very simply, let's look at this again. Now, y is actually the critical point where anything beyond y there is no light, anything within y there's light, and we must imagine that this case happens in a circular patch. So this boundary is the boundary of y. Anything beyond that is out of y, anything within is within y. So from there you realize that we actually form a cone, alright, with a height of 2 meters. This is 49 degrees. So using alternate angle, you realize that this angle here is also 49 degrees. So this 2 meters, 49 degrees, you realize that this is actually a trigonometry identity, alright, opposite adjacent. So opposite adjacent, you have tangent, alright, you have tangent. So tangent 49 will give you opposite adjacent. So from there you find that R is 2.3 meters. Okay, so that's the answer for R. Okay, so that's the answer for the question. Thank you.